Some shooters up there. And they just have a mass shooting up there a couple of weeks ago.
Actually, a couple days ago, in Paris at the cemetery.
Yeah, that's right. I had to laugh at that headline. 3 men found dead today at the cemetery. Well, aren't they all dead? Well, I'm like, wait a minute, what am I? 3 men above ground. We're dead. Yeah, it was it a father and sons or just 3 guys?
I think they were like in their 20s and 30s.
Oh man, that's.
But they had buried them, and the other guy that where the tombstone was, I guess that guy got shot up too. So it's all part of the cartel.
Wow. Is that what they're saying? Ooh. MS-13 or cartel from Mexico?
I don't know.
Wow.
They didn't say.
That's messed up. Now, when we start talking about torque angle, if you have a bolt in an application, if we look at our Cummins bolts, or if you look at the head bolts, if it has these kind of markings on it, okay, what's that? Yeah, whatever. I know what you're doing. You're looking ahead to see how soon I'm going to be fucking done.
I was like, dude, that's the last one already.
Is it really? That's right. I got a couple other things, and I'll try and get you guys out of here about 5. I don't want to go too early with everybody here. We'll catch hell. Because I did that once, and it wasn't Frank. Somebody breathed on my boss, Frank's boss, about leaving early, and then it rolled down the hill. So I'll try and get us out of here about 1 o'clock. 1 o'clock. Fuck that. That'd be a stretch. I'll try and get us out of here about 5. All right, now, if you see a bolt like this tells you this bolt is going into an application that's going to be a torque turn, torque angle, torque template, torque to yield. Okay? This one says on it 90 degrees. Usually, if it's OEM, the bolt will match the spec. And this one, it's a certain value, and then you turn it 90 degrees as indicated. And this is a universal symbol for angle. So if your bolt head has that on it, it's probably, when you remove it, it's probably going to be yielded, meaning stretched. And you should measure it before you throw it back into whatever application it came out of. Okay? Now, you can measure it using the template. Usually, like if you get a, like I said, if you get a Cummins top-end kit, like a head gasket kit, or a complete overhaul kit, somewhere in that kit is going to be a cardboard or plastic template that's going to have a length measurement and holes to measure diameters of the bolts. And if it doesn't fit through the hole and it fits in the length gauge, you can technically reuse it. Okay? So if I've got a whole wad of these bad bears sitting on my table, okay, I know just by looking at it that may have been torqued to yield, and I may want to look at it versus just grab it and throw it back in. Now we're going to reuse the ones we have, obviously, because that engine's going to be like Cousin Vinny. It's never going to work.
It's trained.
It's trained, right? In fact, I'll probably just have you guys torque a couple of bolts because I need to keep those threads as fresh as I can for as long as I can.
We're talking to a lower spec.
We could just clean them out with a tap for you.
There you go. And make sure you put that tap on a drill because we want to do it quickly.
Yeah.
I saw that in, I was at LA Unified and I was teaching the students how to make a hole. Right? So you're going to make a 3/8 hole, you drill it to about 21/64 because you need metal to cut. And I said you run the tap into it. And so I had, a bunch of cables lined up and, everybody's like this and I hear this, what the fuck is that? And there's this total retard looking dude. And I'm like, I'm just shaking my head like, man, there ought to be a license requirement to have hand tools, right? So there's 2 reasons I knew there was a problem. One is using an electric tool and one and all the smoke. So I take the tap out, it's freaking piping hot. And I look at the threads and it looks like someone ran an auger in there. He gets the bolt and he gets about 2 turns on it and he goes and he gets a socket. Okay. Jesus Christ.
It worked.
He said, well, I got it tight, Mr. Tingley, look, it puts it to click. I said, well, yeah, you did what I said, but now loosen it. Now tighten it again. No threads. You didn't tell me I have to use it again. That was a good line. I was like, what'd you think? Funny guy, haha. All right. So in the case of showing, in addition to being tightened at a specific torque, the bolt should be turned 90 degrees. And you can tell that, mark the block, and then mark the bolt, and it actually had a mark over here if it lines up, and he turned it to the 90 degrees. Now, how many of you guys, every time you torque a bolt, whether it's in the elastic, plastic range, or yield, mark it? You should. Because you're gonna get in the middle of a job. Let's say you put an axle flange on, right? And the torque spec that's what, 288 foot-pounds, I think, on an Excelsior.
I think it's 266 on flanges.
Okay, on the axle?
Yeah.
Could be. And that's another reason. Me, myself, I don't memorize specs because they can change. Okay? And sometimes they do.
When you're running the same bus all the time, same.
Yeah. And a lot of guys will memorize them, and that's fine. But I just, well, that's my story. It's just I forget shit, so I don't memorize because I'm gonna fucking forget. So
They
my
sound
story
familiar.
is I don't memorize them because they change. The real story is I forget shit. All
They
right?
sound familiar, you know.
Yeah, yeah. But the reason you'd want to mark them is, let's say you're putting together, you're putting an axle in, you get all the bolts on, and you're in the middle of applying torque, and he says, Gene, you got to go on a road call. They're waiting for you. Get the service truck and split. And you're like, oh, okay. And you take off.
You don't have a warrant. You come back, you don't know what you did.
Exactly, that's exactly where I was going. And sometimes I'll just loosen them all up and try again. Well, on those flange bolts, at least in our manual, if you loosen them up, you got to replace them.
Yeah.
So,
One-time use.
yeah, one and done. So, I mean, how many times are you going to do that? You're still here. We were going to leave at 4:30, but fuck, you're still here.
What did you just say?
Nothing. I didn't say shit. What's going on with all these meetings in here, man?
He's sweating.
For the training tomorrow, the coffee is all set up, you just need to pour the water in.
Wait. Me.
Well, you're gonna be here early, right?
I suppose.
Or just wait till I get in, that's.
Because you know me, I can screw up pouring water in a coffee maker, like, no problem.
That's why he did it.
No, I got it on the floor, shit,
Got a witness, huh?
Toilet water. Oh, I did that one time. I made coffee in here, I think it was for class, and they had a meeting in the conference room. The guy says, well, I got a meeting, where'd you get the water from? I said, bathroom. Scooped it out of the toilet. Nobody drank the shit. I was like, really, you think I do that? And they're like, yes. Hey, Frank, enjoy your banana. We were having class this morning, and Frank said, well, when I was a mechanic, I did a lot of head work. I don't know why, but I got the giggles. And the young lady sitting here started laughing, Vanessa. I see, aren't you glad you came today? And then I'm like, oh. She just lost it, right? She just totally lost. She says, I was going to say that, but I thought I'd offend you. I'm like, are you kidding me? So I'm in the middle of class, and Frank's over there with the banana. He's like, he goes, he's like, I am trying to. He's over there right in the door. No one can see me. He's like, ah. I'm like, oh man, we had way too much fun. That was a good class. Now, a couple other things, and we'll get out of here. When we talk about bolts, like if I asked you to bring me I need a 3/8 bolt that's 2 inches long, right? Most of the time, the mechanic's going to give me a bolt that fits in a 3/8 socket.
Correct.
Correct. But did I technically ask for that?
No, you asked
No.
for a 3/8 bolt, which is a 9/16 head.
Exactly. So what I'm saying is this, that's awesome. In a standard bolt, when I say 3/8, I'm talking about the shank, or the shaft, or the bolt body, not the head. See, this is how we got in trouble this morning. Right. So on a standard American bolt, 3/8 by 20 by 3.5 is I want a 3/8 shank, 20 threads per inch. That happens to be, in this case, 3.5 inches long. Okay? But that's not what most mechanics ask for. They'll say, hey, I need a fine thread 3/8 bolt 1.5 inches long. Well, fine thread, depending, can be 20 threads, 24 threads, 28 threads per inch. It's whatever's in the bolt bed. Now, 98% of the time, he's going to get what he wants, but technically, that's not what he asked for. Okay? On a metric bolt, and I had to look this up, I learned something today. When you look at a metric bolt, it'll say M or N, which is nominal diameter, 10.8 by 30 by 1.25. You're like, damn, that freaking Japs got everything all fucked up. Because I blame everything on the Japanese. They invented the metric system, it's their fault. Okay. I got any Japanese POWs in here? Because I used to make fun of those, and one day I had a class in LA Unified, and I had students that were 17 to 75. That was my student range, right? So I was making fun of Japanese POWs. The one guy sitting there was a Japanese POW, and I kind of felt bad. I said, yeah, you're a Japanese POW in America? He said, yeah. I said, well, we had the Bataan Death March. And he said, what's that? I said, well, yeah, look it up. So the metric, this is kind of interesting though. The 10.8 is the metric's way of tensile. What's tensile strength? You should know that. What does it mean when I say the tensile strength of the bolt?
Isn't that when it breaks?
Well, yeah, that's when you go past it, yeah.
How hard it is.
Interesting, but not correct. How much, well, it has an indirect relation. How far I can stretch it before it breaks. That's probably what you were thinking, right? What?
This guy over
I didn't say that. I didn't say anything.
dying over here. That's what he's saying.
So let me think. No, I'm not even going to go there.
I didn't even say that.
So does Viagra increase your tensile strength is what I was going to say. What this means is the tensile strength of the bolt is 80% of 1,000 kPa, it's a metric way of measuring force, right? Like we have pounds per square inch. This is how they measure force. So if I have a 10.8, the bolt's tensile strength is 80% of 1,000 kilobars. If I have a bolt that's 8.2, it's 20% of 800 kilobars. You see where I'm going with this? So that's their way, that's their equivalent of a grade 8 volt. We measure tensile strengths in grades. Grade 8 volts being the toughest, right? We have 3 grades. Grade 8, grade 5, and I believe it's either grade 3 or 2, and then below. And we mark our bolts, standard bolts. So if I've got a bolt, I've got 6 marks on it. That means it's a grade 8. Why they do this, I have no idea. If I've got 3 marks on it, that means it's a grade 5. And if I've got 1 mark on it, that means it's a grade 3 or below. So the 3 marks would be
Like a peace sign.
and then
That's a 5.
that's a grade 5, right? And grade 3 or below. And also on the face of the bolt, there'll be a manufacturer's mark, a registered mark with the feds. In a lot of cases, you see a little X. Now, Golden State. Let's see if I've got one of theirs. They've got a mark down here. It looks like an omega or a U. So they'll have a registered mark, and that'll tell you the grade and the manufacturer. However, we got a load of counterfeit bolts in about, like I mentioned earlier, a few years back. And at our level, it was almost impossible to tell they were counterfeit until they started failing unusually. and then we had to run them in, and it was a big fiasco. And so Golden West Fastener, or Golden State Fastener, that's who supplies our bolts. Told us they had some markings on the bolt that they use to try and discourage counterfeiters, and one of them's their mark, and they do some other things on the shaft and underneath the head of the bolt to try and discourage counterfeiters. So that's, when you see those, that's a standard non-metric bolt. And your metric bolts are typically and then they'll have the manufacturer's mark on the bottom, and that's all the information you get. Now, when you look at a metric bolt, how you identify a metric bolt, usually you'll see it as 10.8 by 30 by 1.25. Okay, so what that is telling you is the 10.8 talks about the tensile strength. The 30 is 30 millimeters. It's talking about the length of the bolt. And the 1.25 is the thread pitch.
You're missing the bolt size. Like a 10 millimeter, 10 by 30 by 1.5, or
No.
12 by 30 by 1.5. The 10.8 is just how the tensile strength.
So, oh, you mean the diameter?
Diameter.
Oh, okay.
Yeah.
So yeah, M 10 by 8 is what's on the
Head.
top, the head. So, and sometimes it's preceded by M or N, so it might be like N. And the N is nominal. Why that's there, I don't know. So N20, it'll either be N20, M10.8, or M10.8, N20, 30 length, and 1.25 is the pitch of the thread. The pitch is the weight, the lean. Right? Straight up would be 0, and it's 1.25 millimeter pitch. The US bolts count threads per inch. The metric versions, they count the pitch, or the angle of the thread compared to the shaft. It'd be 1.25 millimeters, like that. Okay? And I think the common ones are 1.25, 1.5, 2.5,
There's 1.75, 1.0.
1.75, and 1.0. And they're all, you know, it's like national coarse, national fine, 24 threads per inch, 20 threads per inch, 18 threads per inch, and I think 16 threads per inch. Okay. Now, there are a couple applications where a metric bolt will literally thread into a standard bore, or a metric bolt and a standard nut will thread on the bolt. But if you grab the nut as you thread it, it's got some up and down slop in it. That's because the threads are not a match. They're close, but they're not exact. So should that be used? No, because it won't hold its torque. Okay? If you've got a bolt, you grab another bolt, you want to see if they're the same thread count, or in case of a metric, the same thread pitch. If I hold the two bolts up and the threads mesh and I can't see any light between them, these are the same threads. You're good. These just happen to be metric. But if I hold the two bolts up and I can see light between them, no bueno. Okay, no bueno. Now, the real way to check this thread gauge. It comes in a tap and die kit. This one happens to be metric. And if I want to find out, this is a 0.9, I put my gauge on there just like I did with the bolts, and I find one that I see no light when I put the gauge into the bolt threads. Wow. I'm days.
Make sure it doesn't say it's a standard bolt. You're never gonna find it, I know.
I'm like, what the hell, man? Yeah, let me have some bitch back. Well, see, there you go. Obviously, I was mistaken. Hey, if you can't make fun of yourself, we can make fun of, right? Guys ain't gonna forget that, though,
Keep
are you?
looking for that one.
Hey, you were trying hard too.
I was like, fuck, I gotta get my glasses checked, man. This is not right. That's funny. Oh, it's in here. If
The
you,
last one, like, oh.
it's always gonna be. It also doubles as a mustache comb. Golly, come on, man. Don't make me look really bad.
Just stop grabbing standard bolts when you ever.
Yeah. Well, at least I had enough sense to check. I'm like, wait a minute. Okay, here we go. 1.75. Go ahead and check that out. Okay. It's like, oh, duh. But they make, again, they make those gauges for standard as well. Okay. And the only other thread that's different is National Pipe thread. That's a threaded pipe that you would see in hydraulics or plumbing that seals as you thread it. So it does have a bit of a pitch to it. Okay, and it's in NPF. It'll say NPF 20, meaning 20 threads per inch, but it's National Pipe threaded. If you try and thread that into a standard bore with standard not pipe threaded threads, it may or may not go in.
It also has a
Kind of a taper to
kind
it.
of taper, yeah.
Yeah.
It's hard to tap that stuff.
Yeah, yeah. Now, tap and dies. Okay, again, these are your taps. They're for putting threads in bores. This is a die. It's used for putting threads on round stock. Just round steel too, but a round steel stock. And the die has a side that says start this side because it's tapered, so it gives you some room to start it and turn it down. Can you start on the other side? Yes, it's extremely difficult. Okay. Most guys that are threading straight stock will put a little chamfer at the top to aid in getting this on there and getting it started. Now when you're doing this, you got to keep it straight. You can't be like this. You'll have to get threads that straight. Okay. They come with tools to use. It's a guy at work years ago. He was an odd fellow. He bought a huge one of these and he was cracking walnuts with it. It was big. I mean, it was monstrous. It was something like you'd see in an oil field. And you hear the walnuts cracking. You're like, what? And you'd see him. He'd back this up. You know, whatever works, you know. I just thought it was a little odd. So you put this bad bear in there. Now, it's not a problem to lubricate the threads. In fact, most manufacturers will tell you to put a little oil on the thread because it is a cutting tool. So you want to put some light oil, 10 weight. Now, if I'm going to, I want a hole that's this size with this diameter and those threads in it. If you look on here, this is a 7/16 by 14. So I'm not going to drill a 7/16 hole because I won't have any metal to cut. So this one, I will use a 3/8 drill bit, slightly smaller. That way there's metal for this to cut. And most quality sets will have stamped on the top what size hole to drill. If not, they'll include a chart with the common size holes and the drill bits to use to make that hole. Okay? And usually when you make a hole, okay, you start in, you go about a half a turn, you go half a turn back. Half a turn, 3/4 turn, half a turn back. That gives the debris, the cutting, the shreds when you cut the metal, a chance to work themselves up the flute and out of the bore. If you just, you're going to get debris trapped between your tap and the hole that you're trying to thread, and you're going to get irregular or poor threads. that'll just probably pull out. So you turn it, you back it out, turn it in, a little more, back it out a couple turns, turn it. It's a process.
Especially with aluminum.
Yes, especially with aluminum. Some guys choose to use a 1/4" drive ratchet socket because they're just more comfortable. The problem with that is you might be side loading the tap and going in at an angle. With the T-handle like this, okay, it's easier to keep it centered and straight up because you're applying force equally like this. Okay, if you're good with the socket hand, fine, whatever works for you. Same thing with this. They give you a tool. To use. Okay. And it says right on here, start this side. Snap right on it. So this is the side faces down. And you have this to help center the stock in the bore. As you thread it down, it keeps it from going like this. So you get it going, and when your stock starts appearing at the top of the threads, you put this against it, you tighten it, and it helps keep you like this instead of going like that. Okay, and the same thing, you turn it, back it off, turn it down, back it off. That gives a chance to get the debris off of the die, so you're not got debris getting cut in the threads and you get poor threads. Okay, that's fine. Some guys choose to, again, use a socket and a ratchet. I don't suggest you do that. Okay, and again, you don't want to be the chucklehead with the impact and run it down. I've seen that. And you get augured threads and nothing works. And then you damage the die. It's a low speed tool. It's not meant for, they have high speed dies that are meant to be used with power equipment. Usually that's in a stationary, assembly. Yeah, some kind of assembly where it's usually not done by hand. Okay, this is not that. This is not a high-speed tap. Okay, it doesn't work that way. Okay, now when we talk about engagement, thread engagement, it kind of goes without saying. Give me a minute here, guys. So this is a Blue Point set, which is not bad. Most of my stuff, I don't know, you guys tell me, is Vermont American still around? Because that's where I got all my machining tools.
I think so. I don't know if it's all US anymore.
It may not be. I think the Vermont American was sold off I believe it was the Cornwell trucks. Okay, you can still, I think you can still see them at some of your tool stores. Probably not Home Depot or anything, but some more of your highfalutin tools. Now, when we talk about thread engagement, okay, typically the harder the steel or the softer the metal, the deeper you have to go to apply your clamp load. So for instance, if I'm putting a hole into a piece of aluminum and I want to put threads in it so I can apply a clamping force to it, I'm going to go fairly deep, as deep as I can without breaching the integrity of the component, right? And I'm going to put probably fine threads in it because I'll get more surface contact per inch. And since it's a softer metal, I want as much contact as I can get. And typically aluminum, you're not going to see high torque loads. Now there's always some guy in the airline industries that'll argue with me, well, on a 747, I say, okay, what a different story. Probably got inserts in them anyway. If I'm putting an insert or if I'm making a hole into cast iron, because it's a higher, more dense, harder material, I don't have to go as deep. And then I can use probably something less than 24 threads per inch. Maybe I can go with a 20 or an 18. Okay? And still harder steel, I can go with a shorter bore because of the hardness of the material. Okay? Now, one of the things you have to be aware of as a mechanic when you're You know, oh, I've got this component and it's in the bus and I don't know how big a bolt to put in there because the dude in front of me lost them, right? And you've all been there, right? And it's usually the same dude, right? Two ways you can do this. I mean, you can get you a set of calipers and measure the depth. And this is great for the classroom, but a lot of times you don't have clearance. You can't get this thing in here. I've seen guys get the little drinking straws and stick them in there, bend them in half so they know what size to get. That's fine too. What you want to avoid at all cost like that dude I was talking about earlier. Taking a bolt, threading it in, torquing it, and thinking you've got the torque applied to the two loads and the clamp force has been applied, only to find out later that you bottomed the thing out, and the reason you hit the torque spec was there was nowhere else for it to turn, and the wrench clicked. Like, okay, we're good. And a lot of guys will do that. They'll, okay, it's in. They'll look down, they'll see the washer, and they're like, okay, yeah, it's tight. And they'll move on. What they don't know is that that's a 1-inch hole and the bolt is 1 inch. Now, because of machining tolerances, it might be 1.1/10. Okay. Now, when you measure the length of a bolt, most people go like this. And this is a 6 point, it's almost a 7, what's the scale? God. Yeah, I'm driving home today too. Okay. Inches. So that looks like, that's not 6 inches. That, oh, I'm sorry, that's 1.690, 1.7 inches, 1 7/10. So they'd probably call this a 2-inch bolt, but that's not the correct way to measure it. Okay. What you want to do, most bolts when you measure them are from the bottom of the shank below the head. So when I ask for a 3-inch bolt, I'm looking at okay, so this is almost 1.5 inches. It's 1.470, so we call this a 1.5 inches long. Okay, and it's measured from the bottom of the bolt head to the bottom of the shank. Okay, so there's always manufacturing tolerances. So if I were to use this for 1.5 inches, I'd be okay. Sometimes it might be 1 7/10 inches. And if it's an 1.5 inch hole, it's going to bottom out. Now if I've got a washer under there, that washer is probably 2/10 inch thick, and you won't see a gap. And you're like, okay, click, we're good, and you move on. And you have no clamp load applied. Okay, does that make sense?
So, first we mentioned this a couple times, can you torque a bolt with washers?
Yes. In fact, what does a washer do? Why do I use a washer?
It protects the clamping surface.
Yes, primarily that's what they do it for, but what else does it do?
So that you have more surface?
Explain that, you're on track.
Well, if the hole is the size of the bolt head, if the hole to the opening of the washer is smaller, you get more surface contact between the bolt.
And the other load, yeah, it spreads the force on top of the head on the component. The washer spreads it out a little more. You see what I'm saying? And yeah, it prevents this thing from, and you've all probably done this because I know I have, you go to torque this thing and it starts to dig into the material and you're not at your spec yet.
Yeah.
Okay, would that affect the clamp load? Absolutely. Because now you're not applying a clamp load, you're just augering it into the metal until there's enough resistance from the metal to click your wrench. Right? That's where you were going with.
Yeah.
Okay?
So do you have to worry about your washers being able to take on a certain torque load?
You mean, am I going to squish the washer and crack it?
Like, yeah, like if you have a torque that you're up to 200 pounds, are you going to do the washer?
There's some applications that use hardened washers, so I guess it would be yes.
Say that again?
There's some applications that use hardened washers.
Yes. Usually your high torque turns.
Most aluminum heads, the head is different. The wider the head. the
Yes.
bolt.
Yeah, they'll have the skirt around
Yeah,
it.
enough skirt.
They'll have the skirt around it because they'll spread the force out over a larger surface area. Right. The adage, if it had a washer, put one in. Plain and simple. Now, is it okay to put a lock washer in where there wasn't one before?
Depends.
Explain.
Are you putting the bolt into aluminum? You don't want to use a lock washer. Are you dealing with a situation where something came loose? Maybe you use a lock washer.
Yeah.
Are
Most
you in the
Japanese-
desert? Getting away from the Taliban? Then you just do whatever.
Do what you got to do. Right. Right.
A lot of them use both.
Yeah.
Washer and a lock washer. That's a standard
Lock
assembly. That's a
washer.
standard setup.
Lock washer and a lock washer.
I would all, and this is, again, this, you know, I had a student tell me, well, there's two ways of doing things. There's what you teach us in class, and there's what we do on the floor. And you know what? I got no problem with that. He's exactly right. Okay, there's the textbook method, and then there's how you get away with things on the floor. And a lot of times they're a little different. What the textbook tells me to do is consult the manufacturer whether they want a lock washer and they're not. Did it come with one? Put one in. If it didn't come with one, don't put one in. However, if we're constantly having a problem with this bolt backing out, or the components coming loose and leaking,
Red Loctite.
no, I got one better. Black Loctite, that's aviation.
Ugh.
Green and black. Before I went that route, I would try a lock washer if I've got clearance. If there's enough room to put one in there. If that doesn't fix my problem, if the bolt keeps coming back, I might consider the Loctite route. If that doesn't fix it, you might be looking at safety wire, where you drill a hole through the, you drill a small hole through the bolt head, and you want to wire through it in the locking or the tightening direction, and then you go to the next bolt, and the next bolt, and the next bolt, and the next bolt, and there's no way that thing can back out after that. And a lot of critical items, aviation, just about every bolt is safety wire, right? Or because you know you don't want the bolts holding the wing on backing out in flight. Fun to watch if you're not on a plane, right? So it all depends on what issue you're dealing with. If you got a bolt that habitually backs out, maybe you ought to check the threads. Threads are probably worn excessively. Okay? Or maybe it's that guy with a metric bolt fit and he didn't have the gumption to go get the right bolt because, you know what, it's the end of shift and, you know, I gotta wait for the shuttle to come from bay 18 to the bolt bin and I don't wanna wait. So he says it fit, it tightened up, the wrench clicked, I'm good. Well, no, because it's gonna back out.
JD Weld.
Unorthodox, but hey, Taliban's shooting at me, I don't want the wheel falling off, now I'm going for it. What's that?
You gotta let it dry.
Well, the machine gun fire next to it will warm it up quite a bit, right? So, I mean, like I say, this is kind of you guys made it fun today. This is a hard class to give sometimes because everybody's like, well, what's so special about tightening shit? Now you know. There's a lot more to it than most people think. And that's not necessarily a sign of a bad mechanic because, you know, you're on the floor, you don't have time to take 3 hours on how do you know, everything you wanted to know about tightening a bolt up with a spring gas. But hopefully you got enough information to avoid the common pratfalls that'll get you in trouble, bottoming out a bolt thinking it's tight, not putting a washer on and augering the thing into the aluminum and thinking you've got the appropriate clamp force.
Impact
Right.
everything on.
What's that?
Impact everything on.
Oh, fuck. You know, or you know what? You're gonna lubricate the threads because that's what you were taught and you're gonna do it all the time and you don't know why you keep breaking the bolt. Okay, now you know. You've lessened the friction load, you've stretched the bolt down to its tensile strength. Now let me ask you this. Can I substitute a grade 5 for a grade 8?
No.
Probably not a good idea. Can I-
Depends.
Okay, explain.
Well, if you're clamping two things together that are both metal and you're having a problem with the bolt breaking in a standard use, you could upgrade to a grade 8.
Okay, you're correct. Let me clarify the question. No, you're right. If it came with an OEM, original equipment manufacturer grade 8, and I'm reassembling the components and I lost the bolt, but I've got a bin of grade 5 of the appropriate size and thread. Can I, well, let me back, should I
No.
use the 5 in place of the 8?
No.
No.
No, because obviously the tensile strength isn't there and I'm going to have a failure at some point. Now let me flop this around. Can I replace the grade 5 with the grade 8?
Yes.
Depends.
Thank you. On what?
Like I said, the situation, Obviously, if it's like, for instance, New Flyer does it all the time. They use quarter 20 grade 8s to just clamp a hose to the frame.
Now,
You don't need a quarter 20 grade 8 to clamp a hose to a frame.
what if the bolt is designed to shear a specific situation?
Then that's when you have to use a grade 5.
That's when you get into trouble, and that's the point I was going to make. A point comes to mind, a military winch on an M35 6x. Some of the bolts are designed to shear if you go beyond the capacity of the winch. Well, if I put a grade 8 in there instead of a grade, I think it was a grade 3, and I start going on past the capacity of the winch, I could damage the winch. Whereas with the shear bolt, when it shears, oh, okay, I'll put a block and tackle on it, I'll replace the shear bolt, and we'll try it again. I didn't damage the winch because the bolt sheared. Well, if I put a grade 8 in there, you know, and there goes the gears, I'm like, oh man, I'm kind of screwed. Because the grade 8 didn't shear and the equipment got damaged. A grade 5 might be called for because of, let's say, vibration. And they want the elasticity of that bolt and that clamp force to prevent the bolt from fatiguing and failing. And there's many reasons why it's got a grade 5. So before I did that, right, before I put a grade 8 in place of a grade 5, I might be like, is it a grade 5 for a particular reason? Now, most of you guys got enough mechanical experience, most of us, to look at a situation and determine, well, it's a 5 because of that vibration factor, or it's a 5 because Flyer's being cheap and they can get away with the clamping load and the tensile strength of a grade 5 instead of putting a grade 8 in there. It's a judgment call. Do you make it? Sure. Do most people give it much thought? I hate to say this, but most mechanics wouldn't know a grade 5 from a grade 8. They just go to the bolt bin and grab one, stick it in there, and they don't know any different. Hopefully after today you do. Okay? Okay, questions? Yes, we're leaving now. Okay, and you guys see you watching the clock.
It's moving, that's good.
Oh yeah, you're going back to, oh yeah, you gotta go to Hemet. I will get the hell out of here then. You need to talk to my ugly deformed ass. Let's go, hubba, go. Wait, I gotta close class with go where you need to go. Because one time I said go home and everybody fucking went home and 3 guys got in trouble because they told their boss that I said they could go home.